and welcome to Database Management Systems. I'm Javita Christie, and in this video I'm going to explain B trees and B plus trees. And once again I'm going to start with an example of a B tree, which I also covered in the previous video. So in case you haven't watched, please check the description box for the link. In the last video, I gave an example of a B tree which was of order 3, and in this case I'm going to create a B tree of order 5 and insert all these keys into it. And you can see that this time the keys are alphabets instead of numbers, and that's all right because you can arrange in an ascending order even alphabets, so that's not a problem. And now let's try and create a B tree of order 5 for this particular sequence. So first, and I'm going to go a little bit faster for this one because I don't really need to show a lot of steps. I'm going to do it all at once. Now remember that this B tree is of order 5. That means I can have maximum 4 keys in one node, and one parent can have maximum 5 children. Now in this case, first I'm inserting, because I'm allowed to insert 4 keys at a time, so I'm just going to insert A, G, F, and B. And obviously they will be inserted in ascending order, so it becomes A, B, F, and G. And once that is done, I'm going to insert the next one, that is K. So now I've inserted K, and you know what the problem is. So I'm going to split it, and to split it, this was my previous one where there are 5 keys and my tree is of order 5, so I cannot insert 5 keys. I have to split it, and to split I'm going to use this middle F over here and put it in the topmost level because this level is full. So the B tree always grows upwards, remember that. So this level is full, and that's why I'm going to put it on the level above and put AB on the left of F and GK on the right of F, and this is what it becomes. Now let's go ahead and insert D. So D gets inserted right here because D is less than F, so D is on the left side. And then we can insert H and M. H and M are on the right side of F, and we can insert that without any problem. But the next thing we have to insert is J. So when we try to insert J once again, it falls in this position, but now you can see that the number of values in this node are 5, and I cannot allow 5 values because my B tree is of order 5. So I have to split, and to split again I'll choose the middle element and put it on the top level because there is space, and then put G and H on the left of J and K and M on the right of J. And this is what it looks like. Now my next step is to insert E and S, and I'll insert as many elements as I can without having a problem, without coming into a problem where the node gets full. So I've inserted E, S, I, and R. So E obviously gets inserted here. S got inserted here. I got inserted here because I falls between F and J, so we inserted it here. R falls after J, so R got inserted here. And so far there's no problem, but when I try to insert X, there's going to be a problem, which is again that this node is now full. So when it is full, then we again will take R to the topmost level and put K and M on the left of R and S and X on the right side of R, which looks like this. So this is what it looks like so far. And now we are going to try to insert the remaining letters. So let's say we are able to insert C, but it makes this node full. And because it is full, I have to again pull C up to the topmost level and put A and B on the left of C and D and E on the right of C. So this is what it looks like. And next I have to insert L, N, T, U, and P. So let's see, L comes right here because there is space. N also comes here, there is space. T can fit here without any problem. U can also fit here without any problem. And the last thing left is P. And obviously P should come in this node, but that creates trouble for us because this node is full. So what we will do is we will take M to the topmost level. But as you can see, the topmost level here is having 4 values already. So if you take M up there, then also there's a problem. We need to decide now what would be the position of M in these keys over here. So M would be coming right in this place because it comes before R but after J, and that's why M would be coming here. But when I try to insert, there's a problem. So I have to split this again and create one more level. To create that level, I will take J to the position of the root because J is the middle element. So this is what my tree now looks like. So J is right up here. And let me just go back and show you once again. So J is right, goes up, and on the left side of J, there are C and F. On the right side of J, there will be M and R, which you can see here. So J, C and F, M and R, and that is done. And now what we need to do is what happens to M. So we split M and took it up from here. So on the left side of M, there will be K and L. On the right side, there will be N and P, which you can see right here. So left side is K and L, right side is N and P, and the rest of the nodes sort of fall into place without any problem. So this is what my tree looks like. And now as you can read on top, I'm going to try to delete something because like I said, these are data structures that not just allow you to insert and grow and search, but they also allow you to delete nodes. So we're going to do that. We're going to try to delete because there are some rules that have to be followed while deleting these nodes. And once again, this example I went through very quickly, and if you didn't really get the insertion process, I would suggest that you watch the previous video where I have explained very slowly how to create a B tree. In this video, this is just for the purpose of a revision, and then I just want to show how to delete, and that's why I showed the insertion. So if you find it too fast for you, please go and watch the previous video where I've explained everything very clearly. So now I want to delete E, and E is a leaf node because it's at the bottom and it has no children. So I want to delete E from this node. So what are the procedures that I have to follow? So first of all, I can delete E directly. And the reason for that is because there is nothing present below E. The problem would happen if I had to delete one of the nodes from this level, then it would be a problem. Or if I have to delete one of the root, then it's a problem because it's a tree and it has to have a root. So I have to choose a new root. But in this case, it's just a leaf node and I can just remove it without any trouble. Now, because I removed that, I would have to borrow from the neighbor another node. So let me just quickly explain what happened there. So you can see that here I have these group of nodes. We have this group of nodes. You have C and D, F, G, H, and I. So this is the group that I have right here, from which I removed E. So after removing E, I'm going to borrow from the neighbor and take one node. Now I cannot put G here. The reason is because G is greater than F. So G has to come on the right side of F. If I put it here, it violates the B tree property. And that's why I cannot put it here. But I can move F and take G up. So that is what has been done. I moved F down from its position and took G upwards, and on the right side of G I have H and I. So this is what a removal of a node from the leaf, of a key from the leaf node looks like. Now let's try and remove F. So if I want to remove F, then F is present right here, and I want to remove F. So what should I do? I can remove it directly because again it's in the leaf position, but now there is no space for me to borrow from the neighbor. The reason for that is because if I take G from top and put it here, then H has to take the place of G, and on the right side of H there will be only one node left. So I cannot do that. I cannot borrow from the neighbor anymore. So what do you do in that case? You try to merge the node. So you combine and push the problem up by one level. So what you did is, previously you had this. You had D here, G here, H here, and I here. But what you did now is that you combined and made it D, G, H, and I all in one side, and then C is all alone, and you have on the left A and B, on the right D, G, H, and I. So now the problem is no longer here, the problem is on the level up. So in order to solve that problem, the reason why we are doing this is because there is a fixed number of children that need to be there, and I explained this earlier in my previous video, the rules of creating a B tree. One of those rules is that you need to have, each non-leaf node needs to have at least m by 2 children. So, and m by 2, if it turns out to be a decimal point, then you have to make sure that you take the ceiling value of it. So because that property is getting violated, we have to do all these changes. All right, so that is why we have to do all these changes right here. So here you have C, and then that is not the only thing. The other thing is also that there is a rule that says that there should be k plus 1. If there are k number of keys in one node, then it should be k plus 1 in the next node. And that's why, using those two rules, we need to make a change over here. And what we will do is, since there is a problem right here, we are going to merge these two also. So when we merge, J comes down and J comes right here. So it becomes CJMR. So when we cannot borrow, we combine. And once it is combined, you can see that the size of the tree has now reduced. It is down by one level, and this is what your tree looks like now. So this is your B tree, and this is how you perform deletion in the B tree. Now let's see if we can delete M. Now M is no longer in the leaf position, it's in the root position, and I want to delete M. So what you need to do is, the immediate predecessor in non-leaf is always in a leaf. So that means this is a non-leaf node, but the predecessor of this is present in the leaf node, and the predecessor means a node that is occurring before this particular node. Now what do you do when you want to remove M? You cannot just remove M, because M is attached to K and L, M is attached to N and P, so you have to take care of those nodes. Nobody is asking you to remove those nodes, we are just asking you to remove M. So let's see how to do that. So first of all, you delete M, remove M, then replace M with its immediate predecessor. So let's go back and have a look at it. A predecessor is, like I said, a node that appears in a sorted order before M. So if you actually see, the predecessor of M is L, because it's on the left side. And don't get fooled by this line that's going towards the right. It's just because there's no space here, but this doesn't really mean that it's on the right side. the arrow or the link is coming out from the left side of M. So these nodes belong to the left side of M, and from there the predecessor of M is L. So I have to replace M with L, and this is what I get. After doing that, here there's only K left and L goes upwards. So that part is clear. And then you can borrow from the neighbor. So in the previous step, we saw that K is the only key left over here. So we are going to borrow from the neighbor. To borrow from the neighbor, you are going to borrow not from this side, but from the other side. So we borrowed one value from here. And that's why I is coming. You cannot put I in this position because then it would violate the property that I is less than J and it cannot come to the right side. So we have to put J here and shift I up. So this is what it looks like. So we borrowed J from top and shifted I to the top. And this is how your B tree is actually created, and you can delete nodes from it. So this is all about B tree. And now I'm going to go and talk about B plus trees. So the B plus tree is an interesting variant of a B tree, which brings up the notion of maintaining all data in the leaf nodes. So in a B plus tree, you will try to maintain a copy of all the nodes which are non-leaf nodes. You will try to maintain a copy of those nodes in your leaf nodes, and I'll explain that with an example. So let's create a B plus tree of order 4, and a B plus tree follows all the rules of a B tree. So everything is same except that you will keep a copy of all the nodes in the leaf nodes. So let's see. I want to insert 1, 3, 5, 7, 9, 2, 4, 6, 8, 10, and the order is 4. That means each parent can have a maximum 4 children, and each node can have maximum 3 keys. So let's insert 1. Inserting 1 is very easy. You just have to place it over here. Then we insert 3 and 5. 3 and 5 is also not a big problem. We inserted 3 and 5. Next, we need to insert 7. So to insert 7, there's a problem because when you try to insert 7 here, it makes this node overloaded. So you have to shift something. Now you have a choice. In the previous example of a B tree, we used order 5, which is an odd number. So it's very easy to pick a node. But in this case, order 4 is an even number. So when you put 7 here, it actually becomes 1, 3, 5, 7. And now there is no middle value. You have 3 and you have 5, both are in the middle. So you can pick any one you like. You can pick either 3 or you can pick either 5. So you can choose to pick either the smaller value or the larger value. But if you pick the larger value, then make sure you remember that choice, because later on the same problem is definitely going to happen, and at that time also you have to pick the larger value because you chose the first time to pick a larger value. So I'll just tell you that when that thing occurs afterwards. So now I'm picking 5 to go to the top and 1, 3, 7 to go to the bottom. But there's one interesting change here. I did not just pick 5 to go to the top. I kept a copy of 5 in the leaf nodes, and this is the property of a B plus tree. If this was not a B plus tree, then we would not have picked 5 to go down here. 5 would just be here, but we are maintaining copies of all the nodes in the bottommost part. And this works very well for a database, because if you want a sequential access where you are able to access all the rows of a table starting from the first one to the last one, then you just have to access the leaves of the tree. So that is why we are using a B plus tree. And so there's a copy of 5, and since I am choosing to store 5 on the right side, So if next time I have to store some node, I will again try to store it on the right side. So every time the copy, I'm going to store on the right hand side. And now you can see on this side there is 1 and 3. On the right side there are 5 and 7. The next thing we have to insert is 9, and 9 can easily get inserted here. This was my previous one, and to insert 9 there is a space here, so I can insert 9 directly. Now the next node I have to insert is 2. So this is my previous tree. In this, if I have to insert 2, then 2 is less than 5, and I have space for 2 right here. But obviously I have to insert it in a sorted order. That's why 2 does not get inserted here, but gets inserted right here in the middle, and 3 is shifted. The next thing I have to insert is 4. So this is my previous tree, and now to insert 4, 4 would actually come in this position, but there is no space here for 4. So I have to pick one node, one key to go up on the root. Which would that be? Previously I picked the larger one. So right now also in the middle I have 2 and 3. I have a choice. I can either take 2 up or I can take 3 up. But if you remember, I told you that last time when we picked 5, we picked the larger value. So here also we need to pick the larger value, and the larger value is 3. So we are going to take 3 up, and so 3 is right here. On the left side of 3 there are 1 and 2. On the left side of 3 there are 1 and 2, and on the right side of 3 there are 5 and on the right side of 3, we were trying to insert 4. So on the right side of 3, we have 4, but we need to maintain a copy of 3 also. And that's why we are keeping 3 as well as 4, because a copy of 3 needs to be in the root, needs to be in the leaf nodes. Now the next element that we are going to insert is 6. So this is what my previous tree looks like. To insert 6, 6 is greater than 5, so it should get inserted in a position that comes on the right side of 5. So 6 is going to be inserted in this position right here, and it will go 5, then 6, then 7, then 9. But we know that this position is full now. So I have to pick somebody to go up, and that would be 7, because 7 is larger than 6. So I will take 7 here. As you can see, 7 is taken up here. And the next thing that I will do is split this node. So on the left side of 7, I will have 5 and 6. 6 was the new one I inserted. And on the right side of 7, I'll keep a copy of 7 along with the node 9. And now the next one that I'm going to insert is 8. So where does 8 go? 8 is obviously larger than 7, so it should come in this position, and that's what we are doing here. So 8 gets inserted right here without any problems. And the last thing we are inserting is 10. To insert 10, again, 10 is going to get into this position and will create a problem. So let's see it once again. So 10 is supposed to get inserted here, creates a problem for me, and that's why I have to perform all these steps right here. So let's just, very slowly try to understand what exactly is happening in these steps. You can see that there's one more level increased, and we'll see what happened there. So first of all, 10 can be inserted only in this position, but there's this position is full, which is why I have to pick a node to go up, and that node would be 9, because I have 9 in the middle and it's the larger of 8 and 9. So I'm going to take 9, and 9 goes up. And when 9 goes up, again there's a problem, because we have 3, 5, 7, 9, and that is too much for this level. So again I have to pick some node that can go up, and that node would be 7. So if 7 goes up, I have to make sure that on the left side of 7 I have 3 and 5. So I've done that. Left side of 7, 3 and 5. Right side of 7 should have 9. So there is 9 on the right side of 7. Now, initially we were trying to insert 10 here. So on the left side of 9, there should be 7 and 8, which is here. And on the right side of 9, there should be 9 and 10 because I have to store a copy of 9 in the leaf nodes. So 9 and 10 are right here. So that's my final B tree. And this is how, not a B tree, that's my final B plus tree. This is how you can create a B plus tree, and it's just slightly different from a B tree, but it follows almost all the same rules except that all the nodes are maintained in the bottom, and you can see that right here. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. They are all leaf nodes present in the bottommost level. So all the copies of the nodes are maintained in the bottommost level. That's what a B plus tree looks like. And here I'm going to end this video on B trees and B plus trees. And thank you for watching, and please watch the next video for the last type of index, which is a hash index. See you in the next video.